Hello. In today's video, I will show you how to calculate deadweight loss from a tax on a particular numerical example. What I'm going to do is I'm going to pull out problem 3 from problem set 2. You remember you were supposed to draw the demand and supply diagram in it, so the numbers should be familiar to you. The only thing that I'm doing is I'm extending it slightly to the left from the equilibrium so that you have a little bit more numerical information. So given the demand and supply schedule, the table, we can plot the demand and supply curves on the graph, and you can see that the equilibrium corresponding to the intersection of demand and supply occurs at the quantity of 350 and the price 225. And so if we go back to the table, there's a price at which the market clears because quantity demanded and quantity supplied are equal to each other. And so graphically, it corresponds to the intersection of the two curves at 225 per pound and 350 pounds in the market. So now I'm going to go on and introduce a tax in this situation. And it's a completely unrealistic example because you know that, in fact, governments tend to help dairy producers and rather than taxing them, but it's a convenient example to consider how taxes work. So I'm going to go ahead and I'm going to say, what happens when a tax of 15 cents per pound is introduced? And in reality, it doesn't really matter whether we're taxing consumers or we're taxing producers, but for simplicity, I'm going to assume that it's the producers who are being taxed. So now, on top of any price they receive for the butter that they sell, producers are forced to pay a 15 cents tax per unit to the government. So for example, if they were trading at 225, every time they receive 225, they now need to give 15 cents away in form of the tax. So what happens with the supply curve once the tax is introduced? You can think about the supply curve shifting up or shifting to the left by the amount of tax. So basically, the suppliers with the new tax would say now, okay, whatever the amount we were willing to sell at 225, now we're selling it at 240 to compensate for the additional cost that we are facing with the new tax. For a lower supply, well, the price has to go up by 15 cents. For any supply, the price has to go up by the amount of the tax. That is the interpretation of per unit tax in this story. So think about that. Marginal cost of production increased exactly by the amount that is collected by the government. And so to understand what's going to happen, then shift the supply curve up by 15 cents. You'll get the new yellow supply line that will be the supply with tax. And wherever it intersects with the old demand, you'll get the new equilibrium. So it's going to be 235 per $2.35 per pound, and the new quantity was going to be 330 million pounds per month. So this is a way to determine what part of the equilibrium after tax is going to be. But remember that, in effect, what happened is we just added the tax to the supply curve. And so the producers, while receiving 235, are only keeping 235 minus 15 cents, 220 per unit that they sell. So just like I said in the previous video, in the equilibrium without any taxes, the price should be such that quantity demanded and quantity supplied exactly match each other. And this is what happens at 225. After tax, we need to find a new quantity, and in our case, it's going to be 330, such that the price that the producers are willing to receive, 220, is 15 cents lower than the price that consumers are willing to pay. So we still have market clearing because quantity demanded equals quantity supplied. But now it equals, the two quantities equal each other at two different prices, and the difference between the prices is exactly 15 cents. So we've taken this 15 cent peg, we found where it fits between demand and supply, and this is going to be the new equilibrium. In summary, the new equilibrium is 330 million pounds of butter per month sold. Producers receive 220, consumers pay 235, and the difference goes to the government. So now let's measure the effect of the tax on producers, consumers, and also calculate tax revenue and deadweight loss. So first, let's look at the producers. From the producer perspective, the old price level was 225, but now the new price is only 220, so they're losing 5 cents per every pound of butter that they're selling. But the second part of the bad news is that they're selling less now. They used to sell 350, now they're selling 330. So two things happen. Price falls and quantity falls as well. And so you don't need to know exactly where the supply curve originates and what's going on to the left of 320, which is where the graph ends, because you only need to calculate the change in the producer surplus, not the producer surplus itself. And so you can see that the change in the producer surplus will be the area equal to the small rectangle, and then the area equal to the area equal to the small triangle, and the area equal to the large rectangle, the left border of which is at 0 outside the graph. It's meaningful to separate producer surplus, change in the producer surplus into these two areas, because two things occur. For once, producers are still selling 330, so the area of the rectangle here is the amount of money that they're losing from the units that they are selling after the tax is introduced. The area of the triangle on the right, on the other hand, is the area that corresponds to reduction in producer surplus due to the fact that they're now selling less. And so we can shade them separately. This is how much they're losing by selling at a lower price, and this additional triangle is how much they're losing by selling less than they used to be selling before. And so we can calculate the change in the producer surplus as the sum of the two areas, the area of the rectangle plus the area of the triangle. And I'm going to write down the formula now. For the rectangle, the length of the rectangle is 330. This is how many units are sold after tax. And the height of the rectangle is 5 cents. This is by how much the price fell for the producers. As for the triangle, I'm going to use the fact that it's a right triangle, so I'm going to take half the product of its two sides, and the vertical side is, as usual, 5 cents, the reduction in price for the producers, whereas the horizontal side is the difference between pre-tax equilibrium output and the after-tax equilibrium output. So it's 350 minus 330. So area of the rectangle, area of the triangle. You can pause the video at this point and calculate the expression, the value of the expression, and it's gonna equal 17. And remember that because quantities are measured in million pounds per month, that means that the change in the producer surplus is $17 million per month. This is a reduction in producer surplus. Think of it as a reduction in the revenues and hence the profits of the butter producers. And we can perform a similar calculation on the consumer side. We can say, what happens with the consumers? For them, they used to be buying at 225, now they're buying at 235, and they used to buy 350, now they're buying 330. So we can also think about the change in the consumer surplus as a rectangle plus a triangle, the rectangle corresponding to the higher price that they have to pay for the butter that they're purchasing, and the rectangle corresponding to the foregone surplus from the quantity that they're not purchasing anymore now that the price is higher. And notice the typo, price rises to 235. So there is asymmetry in this market in the sense that we've introduced this 15-cent peg, but consumers and producers aren't hit equally by the tax. For the producers, the price only fell by 5 cents, whereas for the consumers in this example, price increased by 10 cents a piece. And this has to do with relative elasticities of demand and supply, and you'll see more of it in one of the upcoming problem sets. So you'll be able to calculate the elasticity, and then you'll be able to say what exactly is going on with the change in consumer surplus and the change in the producer surplus. And so let's calculate it. The area of the rectangle for the consumers is 330, that's the length of the rectangle, times the price change of 10 cents. The area of the triangle is 20, that's the difference between 350 and 330, times the price change of 10 cents, times 1/2, because we're looking at a triangle rather than a rectangle. Again, pause the video to calculate the number, and the number equals to 34. So the loss, the reduction in the consumer surplus is twice as high as the reduction in the producer surplus in this example, and equals 34 million per month. The next question that I'd like to ask is, how much does the government get in tax revenues in this situation? What is the tax revenue? Well, take the after-tax quantity, that is 330, multiplied by the amount of per unit tax, and you'll get the tax revenue. So that's 330 times 0.15. Take a pause, do the calculation. You should get 49.5 million. And the tax revenue corresponds to the whole rectangle between the consumer price and the producer price, because remember that the height of that rectangle is exactly 15 cents. So again, when we're doing the calculation of the loss in producer and consumer surpluses, it's meaningful to break the changes in producer surpluses and the consumer surplus as rectangle plus triangle, because the rectangles are what the producers and consumers pay in the form of the tax revenue. They're still trading in this market with tax, but a certain value that this market generates is extracted from the market in the form of the tax revenue. Whereas the triangles is the loss from the tax, because these are potentially gainful trades that do not happen with the tax that would have happened in an unregulated market without a tax. So how much is the deadweight loss? Well, you can calculate it by looking at the triangle with a base of 15 cents, that's the amount of the tax, and a height of 20, that is the difference, the reduction in quantity, so 20 times 15 cents times 1/2, that should be 1.5 million. And so now notice what we've done. We've calculated the change in the producer surplus, and we calculated the change in the consumer surplus, and we said that the first one is $17 million, the second one is 34, for a total of 51. And we've calculated the tax revenue and deadweight loss, and unsurprisingly, they would add up to the same $51 million, because in effect, what is happening is that we're calculating the area of one and the same region twice. First by splitting it into 2 rectangles and 2 triangles, and then by splitting the same very region into 1 rectangle and 1 triangle. And given our calculations, we can be more precise about what's going on in this picture. So going back to producers and consumers, producers are losing $17 million per month total, 16.5 of which are going to the government in the form of tax revenue, and half is deadweight loss in the form of foregone value from trades that did not happen. Consumers, on the other hand, lose $34 million total, 33 of which goes toward the government in terms of the tax revenue, and 1 is the waste of the trades that did not happen. And if you add up the 2 areas of the rectangles, you'll get the 49.5, the tax revenue, and if you add up the areas of the two triangles, you get 1.5 the deadweight loss. So this is the breakdown of what is going on in this story when a 15 cent per unit tax is introduced into a competitive market. Thank you.